Namaskar. Very warm welcome to all the viewers and learners in this very special session of CIT and CRT. I am Renu Bhatt with you all, and you are watching us live on eVidya channels, channel number 12, and apart from this channel, you are with us on our YouTube channel as well, that is ncertofficial Official. और इस सेशन में हम बात करने वाले हैं फिजिक्स के 12th स्टैंडर्ड के स्टूडेंट्स के लिए एंड द टॉपिक दैट वी आर गोइंग टू डिस्कस टुडे इन दिस स्पेसिफिक सेशन इज द ओडिसी ऑफ इलेक्ट्रोमैग्नेटिक वेव्स। इसके बारे में आपको डिटेल में इंफॉर्मेशन देने वाली हैं हमारी एक्सपर्ट जो हमारे साथ स्टूडियो में जुड़ चुकी है। तो विदाउट एनी फर्दर डिले लेट्स क्विकली मीट हर। यू आर मिस प्रीतिका धवन, वेरी वार्म वेलकम मैम।
थैंक यू सो मच।
और आप सभी को हम बता दें कि हमारी जो एक्सपर्ट हैं प्रीतिका मैम, वो फॉर्मर असिस्टेंट प्रोफेसर हैं शिवाजी कॉलेज यूनिवर्सिटी ऑफ दिल्ली से। और आपके मन में कोई भी क्वेरी आए, इफ़ यू वांट टू नो मोर अबाउट इलेक्ट्रोमैग्नेटिक वेव्स, तो आप अपनी सभी क्वेरीज, अपने सभी डाउट्स हमारे एक्सपर्ट्स के साथ शेयर कर सकते हैं। आप हमें कॉल कर सकते हैं हमारे टेलीफोन नंबर पर जो है 8800440559, और आप हमें ईमेल भी कर सकते हैं। हमारा ईमेल एड्रेस आपको अपनी टेलीविज़न स्क्रीन पर नज़र आ रहा है जो है dth.class12@cit.nic.in। अगर आप हमारे यूट्यूब चैनल पर हैं यानी कि NCERT ऑफिशियल यूट्यूब चैनल पे हैं तो लाइव चैट बॉक्स में जाकर अपना कमेंट ड्रॉप कर सकते हैं। ये सबसे तेज़ माध्यम है हमसे जुड़ने का, और हम चाहते हैं आप हमसे ज़्यादा से ज़्यादा अपनी क्वेरीज, अपनी बातें शेयर करें, और कुछ आप शेयर करना चाहते हैं, अपने एक्सपीरियंस हमसे शेयर करना चाहते हैं तो भी आप कर सकते हैं। तो हम अपनी एक्सपर्ट के पास चलेंगे। प्रीतिका मैम, हम आपके पास आएंगे, और जैसे हमने बताया कि आज का हमारा जो टॉपिक है वो है द ओडिसी ऑफ इलेक्ट्रोमैग्नेटिक वेव्स, यानी कि आप ढेर सारी बातें इलेक्ट्रोमैग्नेटिक वेव्स के बारे में हमें हमारे साथ शेयर करना चाहते हैं, साझा करना चाहते हैं। तो मैम, इसके साथ हम मतलब चाहेंगे कि आप जल्द से जल्द ये सारी बातें शेयर करें, पर क्या कुछ स्पेसिफिक टॉपिक आपके पास है, क्या कुछ स्पेसिफिक पॉइंट्स हैं जो आज क्या इस चैप्टर में आप डिस्कस करने वाले मैम?
Well, I would like to explain the overview of what electromagnetic waves are, where we actually use it, and what are its applications, where my whole physics revolves around this integral part, and what are the mathematics behind it. So all these things are going to be the part of this session.
ओके, तो ये कंटेंट रहने वाला है हमारे आज के इस सेशन का, और मुझे लगता है कि बहुत ही इंटरेस्टिंग चैप्टर ये होने वाला है। सो डियर लर्नर्स, अगर आपकी कोई भी क्वेरी हो इस पर्टिकुलर टॉपिक से जुड़ा हुआ तो ज़रूर हमारे साथ शेयर करें। एंड मैम, आई वुड रिक्वेस्ट यू टू स्टार्ट दिस सेशन मैम, डिस्कशन।
Yes. So I welcome all my students fraternity out there. So let's get started. So if I would like to start the topic of the day, I would like to just bring into a highlight or a contrast on the difference between waves and oscillations. So the topic of our concern is today electromagnetic waves. तो यहाँ पर waves की बात हो रही है, but all of us as the part of physics learners, हमने ये कभी ना कभी एक oscillation word ज़रूर पढ़ा है. So today in the very first introductory part, I would like to decipher the difference between waves and oscillations. So if you can see on the screen, we have two things to visualize the effects of waves, and in the bottom we have to visualize the effects of oscillations. So waves characterized by the propagation of energy through a medium without any particle movement, in contrast with oscillations, which involve repetitive variation around a central value or between different states. So if I would like to explain this, if you have, let us consider the case of a simple pendulum. In the case of that, we have a pendulum going from its mean to extreme position and coming back to mean, and then going to the other extreme and coming back. So it is a kind of oscillation. That is something which is there in the space itself, in the time period itself. It is not traveling in space. However, if this disturbance, if the oscillating disturbance begins to travel in space, unlike pendulum it is localized, yeah, it's oscillating. But waves may, if the disturbance in addition to oscillation, if it begins to travel through space through a parameter called as XYZ or R, then we say that that becomes a wave. Point number 2, while waves propagate through space, oscillations occur around equilibrium points. As I've said, oscillations occurs about mean position designated as equilibrium points. However, they have the characteristics, waves have the characteristics to propagate through space. Now, waves comes in two main types, longitudinal and transverse, while oscillations can be characterized as damped, undamped or forced. So, eventually any pendulum is oscillating, it will come to rest. So, what we call that oscillation as a damped oscillation. It is losing its energy and hence it is not able to retain, to go back to its extreme position again. So, that is called as damped oscillations. Undamped is without, it is oscillating in a simple harmonic way, no damping is there. Forced is you are providing an external force. However, for waves, इनकी characterization दो keywords से होती है, and what are they? Longitudinal and transverse. Now, what are the meaning of these words? If the direction of propagation, if the disturbances are oscillating up and down to the direction of propagation, so that becomes a perpendicular vibration. In that case, it becomes a transverse wave. However, if the oscillations are oscillating, disturbances are oscillating back and forth along the direction of propagation of wave, जिस direction में wave ने travel करना है, उसी direction में disturbance आगे पीछे oscillate हो रही है, उस तरह की waves को हम क्या बोलते हैं? Longitudinal waves. Point number next. Mechanically or electromagnetically driven oscillations serves as sources of waves. So, there has to be a driving force for waves. That becomes a source, that we call it as source. Whereas, waves are generated by propagation of energy. So, this disturbance which is oscillating, when it begins to travel, it takes along with not the particles, material या particle को ही अपने साथ नहीं लेके जाता, but it carries with it the energy. For example, I am speaking and the person sitting next to me is listening. तो मेरे माउथ में जो vocal cords या larynx box में जो भी oscillation हो रही है, that is traveling. ऐसा नहीं है कि यहाँ के air particles are traveling through the airs of the next person, but the air is serving as the medium which is carrying the energy, which is the disturbance, which is the back and forth compression and rarefaction coming. The disturbance source is my larynx box and it is reaching to the detector, which is the airs of the person sitting next to me. So, what do we infer? Oscillations have temporal periodicity. मतलब अगर मैं पेंडुलम की बात करूँ सिंपल हार्मोनिक मोशन की, तो पेंडुलम में when it has a certain time period कि एक्सट्रीम से मीन, फिर दूसरा एक्सट्रीम, फिर मीन, फिर फाइनली उस एक्सट्रीम तक आने में जो पर्टिकुलर टाइम पीरियड लगता है इन अनडैम्प्ड mechanism, that is called as time period. So, after passing of every same time, it will reach to that extreme position. Again, that time is elapsed, it will reach to that extreme, and so on. So, what do we infer? Time period of oscillation. That is the periodicity factor in oscillation. Unlike that, waves have two kinds of periodicity, and those are temporal and spatial. Temporal means in time period. So, 1 upon time period means frequency. In spatial means in space. The periodicity also occurs in space. We will see in the next few slides. So, spatial periodicity, what will it give rise to? अगर temporal periodicity time period factor देती है तो spatial periodicity wavelength parameter देती है. So, waves are characterized by two parameters, time period and wavelength. Time period aka frequency of wave versus wavelength of wave. So, both are interrelated when we specifically talk about the topic of the concern, which is electromagnetic waves. So, you can see this oscillation and waves pictures again. Yes, coming back to the next slide, we see the difference between mechanical and non-mechanical waves. So, now we are going into the topic of waves. So, we bifurcate into two topics, which is mechanical versus non-mechanical. So, first I'll start with a definition to mention the contrast between the two. Mechanical waves require a medium for propagation, and thus that medium can be air, water, solids, whereas particles of the medium oscillate back and forth, and you can add up and down as the waves passes through. For example, you have seen in the video of light waves, water waves, and here you can see it for sound waves, right? Now, unlike mechanical waves, non-mechanical waves, for example, which you call it as electromagnetic waves, do not require a medium for propagation, and it can even travel through a vacuum. For example, the sunlight coming from the sun and reaching the earth every morning, that is, it does not require any medium. There is no medium out there in space. So thus, these kind of waves which are non-mechanical, they do not require, they are not medium dependent. However, the velocity is, we'll talk about it later. Point number 2, examples. The sound waves, water waves, seismic waves during earthquakes, and waves in a stretched spring. These all are the examples of mechanical waves. This can be longitudinal or transverse, as I mentioned earlier. However, if I want to give an example of electromagnetic waves, things can be light waves, radio waves, ultraviolet radiations, UV, visible, gamma radiations, and so on. Now, next, as I have told you, it requires medium. The other one can even travel through an empty space. However, what is the key difference? When a string is oscillating, it is giving you transverse waves. It is the particles in the string which are coupled to one another, it is having disturbance in them, and they are transferring it to the another particle, and so on. However, in the electromagnetic waves, they can travel through empty space. Why? Because they consist of varying electric or magnetic field that propagates through space. So I will come to this point. I will highlight this point through the most famous Maxwell's equation in the coming slides shortly. Now let's talk about the transmission. They propagate through the transfer of kinetic energy from particle to particle in the medium. Unlike that, non-mechanical waves, they propagate through the oscillation of electric and magnetic fields. चलिए वहाँ तो particle, mechanical wave में particle में disturbance oscillate हो रही है, लेकिन यहाँ पे क्या चीज़ है? Is there any particle? जब medium ही नहीं है तो particle की भी बात नहीं हो रही. Then what is oscillating? So it is two vectors which are oscillating and hence creating electromagnetic waves. Such entities are electric field vectors and magnetic field vectors. ये दोनों के simultaneous oscillation से एक दूसरे को generate करता है, दूसरा पहले को generate करता है, and simultaneously it gives rise to what is called as electromagnetic waves. And what is the peculiarity of it? These vectors, electric field, magnetic field vectors, oscillate perpendicular to the direction of motion, direction of vibration. So that we will come shortly, but the conciseness of this slide lies in, from the sound we hear to the light we see. Is that it? We are listening sound, that is a mechanical wave. We are seeing the stuff around us, that is, of course, every layman knows that's a light wave or visible wave. क्या यही है बस, या इसके आगे भी है? Why there is a need to define this thing called as electromagnetic waves and hence electromagnetic spectrum? It is not restricted to it. So the answer of this is no. So let's go ahead with what we mean with electromagnetic wave. So this is the form of energy that travel through space, carrying both electric and magnetic fields, as I have just mentioned. They encompass a wide range of frequencies and wavelengths, collectively known as the electromagnetic spectrum. So अगर electromagnetic spectrum की बात करें तो light that is coming from the sources around me right now, this is just a small part of this huge electromagnetic spectrum. And what is it used for in the today's technological world? This has a widest range of applications, from your mobile phones to the computer in front of me, to the messages I'm receiving, to the that radio FM channels I'm listening, even to unravel the mysteries of physics and chemistry and biology. This is an important probe. This is an important tool. What? Electromagnetic waves. Now, going ahead. Electromagnetic waves do not require a medium for propagation, unlike mechanical waves, that is just we have discussed. They can travel through vacuum. Point number next. They travel with the speed of light. Now, why they travel with the speed of light? Because they don't have any medium, they have photons in itself. So, wave as a collection of photons and without any medium. So, this is where we defined with the concept of what is called as light. Speed, light has the maximum speed out of all the particles in the nature. And EM waves travel with that maximum speed of the order of 3 into 10 to the power 8 meters per second. Now, components of electromagnetic waves, as I've just discussed, it's electric field and magnetic field. And what is electric field? The charged particles generate in their vicinity electric fields. Now, if the charged particles are moving, it means moving charges in a current, and the current is there, it will give rise to what? Magnetic field. So, both are interrelated, and to be more specific, I will refer to Maxwell's equation. Okay. Going ahead with the spectrum of EM waves. EM waves हैं, variety of EM waves हैं, इनके collection को हम एक नाम दे देते हैं, इनके different frequencies, wavelengths, energies होती हैं. So इस पूरे के collection को हम बड़ा सा collection, उसका नाम क्या दिया हमने? Spectrum. Spectrum of variety or wide variety of wavelengths and frequencies. Namely radio, micro, infrared, visible, UV, X-ray and gamma rays. And कईयों के applications तो आपको सुनते सुनते ही पता होंगी ज़रूर. So to be specific, its applications lies in communication, medicine, MRIs, astronomy, technology, radio communication, microwaves in the kitchen ovens, then infrared thermography, there is a scanning thing at every metro station, you put your bags into that scanning machine and it gives the imaging. Have you ever wondered what is that? Question mark. So, medical imaging, remote sensing, etc. So, you can go ahead, just venture the things which is, just get into the things which is there around you and apply the knowledge of physics to it, and it will suit you and your interest. So, if I talk about the characteristics and features of EM waves, it as mentioned on the screen. I have told you it has two things, wavelength and time period. Time period aka frequency. So two periodicities are there to characterize it. Not only this, apart from periodic parameter, what else is there that attributes to this definition of wave or EM wave? It is its varying displacement, which is varying amplitude. Amplitude is a maximum one, but the varying part, for example, amplitude of electric field is maximum at crest and trough at this particular locations, crest, 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 trough, 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 trough. So there you have the maximum of electric field which is oscillating and maximum of magnetic field also which is oscillating. However, there is a variation, sinusoidal or cosinusoidal, as you can see on the screen. So this is the electric field intensities, which is strength of electric fields or magnetic field, which is varying, then coming back and then increasing and then coming back and increasing. So such kind of sinusoidal variation of electric field is giving rise to magnetic field and vice versa. So these are the attributes, namely the variation with respect to x and t. x मतलब wavelength से space की बात हो रही है, frequency से time की बात हो रही है. So these variations are happening in x and t, space and time, and two periodic parameters are wavelength and frequency. Next, इलेक्ट्रोमैग्नेटिक वेव्स. तो कई बार हमने अब पढ़ा है कि वेव्स हैं तो भाई लाइट एज अ पार्टिकल भी होता है. यस, वी हैव वेराइटी ऑफ डिफरेंट टॉपिक्स और सब्जेक्ट्स ऑफ फिजिक्स and every topic is very much in detail, so I will touch it, however, because it's just related to somewhat my topic. So electromagnetic radiations have the properties of that of waves, but they also serve as series of discrete particles. And what are the applications or the examples or the experiments which testify to it? It is there in, if you want to study light as waves, कि wave की तरह behave कर रही है, तो क्या क्या study करेंगे हम? Interference, diffraction, polarization, reflection, refraction. अगर आपको light as particles या waves as particles की तरह study करना है, तो what kind of phenomena will you study? Photoelectric effect, Compton scattering, electron photon scattering. Not going into it, but that is the truth. However, Since both are simultaneously possible, so it gives rise to what is called as wave particle duality. Yet another day we will discuss over it. So coming to the topic again, what is the physics behind it? How I can apply mathematics to it? You know, if I want to study it in a physical form, it is just not only in a story form. Definitely I have some mathematical principles governing or ruling to explain my physical phenomena under point of view right now, which is electromagnetic waves. So Maxwell has come up with his set of 4 equations, which happens to be the foundation of this electromagnetic theory. And by this time I hope you guys have understood why this electromagnetic word is joined. Right? Electromagnetic. It is not a separate electro waves, magnetic waves. No, it is electromagnetic waves. Hence, electromagnetic theory. This is governed by 4 equations, and I am going to discuss it because that lays a fundamental of, you know, your physics, the core physics which you are studying. So now it is developed by James Clerk Maxwell in 19th century. Maxwell's equation unified the theories of electricity and magnetism, demonstrating that electric and magnetic fields are interrelated phenomena. So they revolutionized physics, providing a framework for understanding and predicting electromagnetic phenomena. They have numerous practical applications including telecommunications, electronics, electromagnetic wave propagation, electromagnetism in engineering and technology. You know, these are just the topics. We can go into it as and when we want. So coming to the point number 1 or equation number 1, it's stated as Gauss law for electrostatics. What does it describes? How electric charges generate electric fields. It states that electric flux through a closed surface is proportional to the total electric charge enclosed by the surface. So if there is a closed surface and electric charge is there, it will give rise to that electric flux through that surface in the vicinity of that charge. So that is called as Gauss law of electrostatic. However, you know, the word is static here. It means that charges are at rest. It is giving rise to electric field. But does it give rise to electromagnetic field? No. I've said now as in the beginning, the charges when move, it gives rise to magnetic field. But again, the magnetic field which is generated is also static. क्या वो static electromagnetic waves दे सकता है? The answer is still no. Then what is the answer? So we'll come to that. Equation number 2, Gauss law for magnetism. It states that there are no magnetic monopoles. Magnetic field lines always form closed loops. Describes how magnetic fields are generated by magnetic charges which do not exist. Magnetic flux through any closed surface is 0, governed by this integral. This is a surface integral, by the way, double integral. What does that mean? For example, if I say positive charge gives rise to electric field radially outwards, right? The direction of electric field is radially outwards. As a negative charge will give rise to electric field pointed radially inwards. तो हम हर केस में अकेले चार्ज की बात कर रहे हैं. ऐसा किसके साथ नहीं कर सकते हम? मैग्नेटिक मोनोपोल्स के साथ नहीं कर सकते. मैं ये नहीं कह सकती कि नॉर्थ पोल मैग्नेटिक फील्ड दे रहा है या साउथ पोल मैग्नेटिक फील्ड दे रहा है. टेक अ मैग्नेट, break into pieces. Even the smallest, least visible that piece of magnet जिसको आप ब्रेक करके उठाओगे, उसके अंदर भी 2 पोल्स होंगे, नॉर्थ एंड साउथ. कभी भी आप मैग्नेट को तोड़ के उसको पोल्स को अलग नहीं कर सकते. दैट व्हाट दिस लॉ नंबर 2 states. So north and south pole exist in conjunction with each other and hence जो magnetic field lines ये जो देते हैं ना, they are in loops. Unlike charges radially outward in one, they give magnetic field lines in loops because you can never separate south pole from north pole of a magnet. Coming to equation number 3, it is stated as Faraday's law of electromagnetic induction. It describes how a changing magnetic field induces, understand this word induction, induces an electric field. It states that the electromotive force EMF induced in a closed loop is equal to the negative rate of change of magnetic flux through the loop. What does that mean? When there is a change of magnetic flux and that too negative rate of change, negative say Lenz's law and so on, you are touching that, but there is a change of magnetic flux governed by d by dt of integral surface integral b dot ds. This changing magnetic field is giving rise to EMF governed by integral line integral E dot dl. But this integral, it means it is changing magnetic field is giving rise to the parameter E, which is electric field. So yes, the main parameters are flux and EMF, but inherent parameters are changing magnetic field through a surface giving rise to electric field and hence electromotive force through a closed loop. Coming to the next and the last Gauss law, last Maxwell equation, that is called as Ampere's law, Ampere's circuital law with Maxwell's addition. I have incorporated the correction already with this term called as Maxwell's addition. Now it describes the relationship between electric currents and magnetic fields. Maxwell's addition to Ampere's law accounts for the displacement current which arises from changing electric fields and contributes to the total magnetic field. अभी तक क्या था कि हमारे पास इलेक्ट्रिक फील्ड, हाँ ठीक है, चेंजिंग आपके पास इलेक्ट्रिक फील्ड भी किस को राइज कर सकती है, जैसे चेंजिंग मैग्नेटिक फील्ड इलेक्ट्रिक फील्ड दे सकती है, क्या चेंजिंग इलेक्ट्रिक फील्ड भी मैग्नेटिक फील्ड दे सकती है? So that was the addition. Prior to that, B dot dl is equal to mu naught I, as you can see in this case. I represents conduction current. So that was a prior case. However, this addition which is being taken care by Maxwell by studying displacement currents in the sense of studying capacitors, that is also a true factor, that changing electric flux with time is a contribution, is an adding contribution to the magnetic field B dot dl. So what does that implies? In the case of static electric field, the line integral of the magnetic field around a closed loop is proportional to the total electric current. Now the total electric current is conduction plus displacement. Displacement किसकी वजह से आ रहा है? Changing electric field की वजह से. So ये चारों लॉ की completeness क्या बता रही है? ये changing electric field magnetic field को generate कर रही है, तो changing magnetic field electric field को generate कर रही है. It means they are related. As soon as one is generated, अब दूसरा उससे generate हो जाएगा. तो क्या अब क्वेश्चन बात आ गई, तो क्या स्टैटिक से स्टैटिक मैग्नेटिक फील्ड ही अपने आप में इलेक्ट्रिक फील्ड जनरेट कर देगी, या स्टैटिक मैग्नेटिक फील्ड ही अपने आप में EM वेव्स जनरेट कर देगी, जिसका आंसर हमने नो बोला था. Then what is the inherent thing which will give rise to EM waves utilizing all these four equations? So let's see that as well. So how are EM waves generated? Typically, an electric field emerges from a charged particle influencing other charged particles by exerting a force on them. Positively charged particles move in the direction of the electric field, whereas negatively charged particles move in the opposite direction. On the other hand, a magnetic field arises from a moving charged particle exerting a force on other moving particles. This force is always perpendicular to the particle's velocity, altering only their direction of motion without affecting their speed. Consequently, electromagnetic fields stem from accelerating charged particles, giving rise to electromagnetic waves that traverse through free space or as coupled electric and magnetic fields at the speed of light. What does that mean? You know what? The charges at rest, static charges, they are in motion, giving rise to E and magnetic fields. But what about the waves? Waves have this a part of this oscillating disturbances which is traveling. It means, अगर मैं example से बात करूँ, if there is a sinusoidal disturbance और वो electric field उस sinusoidal variation में generate होनी है, उसका क्या मतलब है कि मेरे पास जो charge है वो static तो नहीं होगा, क्योंकि static charge आपको कभी भी oscillating electric field नहीं देगा. So charges कौन से हैं कि E generate हो? It is accelerating charges, which is giving rise to this varying electric field, which you call sinusoidal electric field. And same is the case with varying magnetic field in sinusoidal fashion. So this is basically coming from not static charges, not moving, just moving charges, but accelerated charges. So it gives rise to both coupled electric and magnetic fields. Hence, it gives rise to EM waves, which is traveling in that disturbance of E and B traveling in space and time. So when a charged particle oscillates around its equilibrium position with a frequency f, it generates an electromagnetic wave with the same frequency f. So charged particle की भी क्या equation है? That it is also in oscillating mode, and this oscillation is traveling, giving rise to EM waves with the frequency of f and wavelength of lambda. So electromagnetic waves, finally what do we infer? It serves as the carriers of energy across the space. It is not carriers of particles, I repeat again. It is the carriers of energy across the space. So coming to again the mathematical representation of these waves. We know that there is two vectors, in coupled sense they move. So if I will talk about electric field vectors, moving in, let us say, x direction only. Mind it, this is a simplified picture. At time t, moving in only x direction. This is not a practical case but a special case. So what will be inferred? It is designated by first the amplitude E naught vector cos kx minus omega t plus phi. आपको याद है ऑसिलेशन में हम क्या लिखते थे? y is equal to amplitude a cos omega t plus phi. वहाँ पे kx वाला फैक्टर नहीं होता था क्योंकि ऑसिलेशन स्पेस में ट्रैवल नहीं करती. Since waves travel in space, so here is that space factor and time factor. Both are there. Space factor कौन सी periodicity दे रहा है? Spatial periodicity lambda. K is equal to 2 pi by lambda. And omega t factor कौन सी periodicity दे रहा है? 2 pi by t, which is 2 pi nu. Nu is the frequency of EM wave. So this is giving you temporal periodicity. And phi is the phase. It is initial phase, you can say. So we have vectors. It can travel in all the directions. However, the direction of propagation of this wave is x. This is the direction that this is the the strength of electric field along all the three directions, this E. But the traveling direction of wave is x. Same is the case with magnetic field vector. So E, it has three components in either directions, but the traveling is here as designated here is x. अगर मैं x की जगह r वेक्टर लिख दूं या ऊपर भी e वेक्टर कॉमा ब्रैकेट्स r वेक्टर कॉमा t लिख दूं, तो दिस मीन्स कि ये इलेक्ट्रिक फील्ड वेक्टर कौन सी डायरेक्शन में मूव कर रहा है? एक पर्टिकुलर r वेक्टर की डायरेक्शन में, विच इज xi कैप प्लस yj कैप प्लस zk कैप. फेयर इनफ. टू सिंप्लीफाई इट, हमने यहाँ पे x डायरेक्शन ली है. बट आप इस चीज को ध्यान रखिए, एज यू कैन सी राइट, इलेक्ट्रिक फील्ड एंड मैग्नेटिक फील्ड आर परपेंडिकुलरली अलाइंड, और इनका डायरेक्शन ऑफ प्रोपगेशन इज आल्सो परपेंडिकुलर. सो ऑल दीज थ्री आर म्यूचुअली परपेंडिकुलर. अगर y एक्सिस में मैग्नेटिक फील्ड है, z में इलेक्ट्रिक फील्ड है, तो कौन सी डायरेक्शन में प्रोपगेट होगी मैग्नेटिक वेव, EM वेव? इन x डायरेक्शन. तो अगर ये प्रोपगेट हो रहा है, कुछ चीज ट्रैवल हो रहा है, तो उसकी वेलोसिटी होती है. एंड हमने जैसे बात की, वेलोसिटी ऑफ इलेक्ट्रोमैग्नेटिक वेव इज c, स्पीड ऑफ लाइट 3 × 10⁸ मीटर्स पर सेकेंड. इसका क्या मतलब है? क्या इसको भी हम निकाल सकते हैं? डेफिनेटली. एंड व्हाट इज द फॉर्मूला फॉर दैट? इट इज modulus of E vector upon modulus of B vector, or amplitude of E naught electric field upon magnetic field, which is 1 upon square root mu naught epsilon naught. We can go into derivation later, but this value is from this mu naught and epsilon naught is this 3 × 10⁸ meters per second. Again in free space. अगर यही EM wave को आप किसी एक ऐसे स्पेस से गुजरवाओ विच इज हैविंग अ रिफ्रैक्टिव इंडेक्स, उसका कुछ अपना रिफ्रैक्टिव इंडेक्स है, तो ये वेलोसिटी कम हो जाएगी. ये फ्री स्पेस की बात हो रही है, ट्रैवल्स विद द स्पीड ऑफ लाइट. सो अगेन इफ इट इज नॉट इन फ्री स्पेस, द वेलोसिटी ऑफ EM वेव इज गवर्न्ड बाय म्यू नॉट की जगह म्यू हो जाएगा, एप्सिलॉन नॉट की जगह एप्सिलॉन. परमिटिविटी, दैट इज एब्सोल्यूट परमिटिविटी, दिस इज permittivity of the medium, that is absolute permeability, this is permeability of the medium. तो वो फैक्टर चेंज हो जाएगा, विच इज गिविंग राइज टू C upon N, विच इज द रिफ्रैक्टिव इंडेक्स ऑफ द मीडियम. सो यस, अगर एक मीडियम का अपना रिफ्रैक्टिव इंडेक्स है, मतलब वो डेंसर है एयर से, तो उसमें जो EM वेव की वेलोसिटी क्या हो जाती है, घट जाती है बाय अ फैक्टर ऑफ 1 upon N टाइम्स C. Yes. So with this, with mathematical explanation, we come to some more attributes of electromagnetic waves, namely, अगर EM wave है, उसके अंदर charges oscillating है, which is traveling, electric field vector is there, which is traveling, which has x and t factors, same as the magnetic field vector. It means it is carrying energy. And energy बोले तो हम direct energy की terms में बात नहीं करते, हम energy density एक attribute है, उसकी terms में बात करते हैं, एक parameter है. And what is that? क्योंकि इसमें दोनों ही तरह के features है, तो it is a sum of both the kinds of contributions from electric field as well as from magnetic field. And what is its units? Joules per meter cube. So हम क्या पर यूनिट वॉल्यूम में कितना EM वेव एनर्जी दे रही है. रैंडमली हम बात नहीं करते जूल्स, हम यूनिट वॉल्यूम में वो कितनी एनर्जी ट्रांसफर करते हैं. एंड इट इज गवर्न्ड बाय 1/4 quarter of epsilon naught E naught square plus quarter of B naught square upon mu naught. You can go into the derivation and use various numericals to solve it. Next, intensity. अब भाई इंटेंसिटी है, क्या हम इंटेंसिटी इज ऑल्सो वेरी स्पेशल पैरामीटर वाइल डिस्क्राइबिंग दिस थिंग. इंटेंसिटी किसके प्रोपोर्शनल होती है? इट इज प्रोपोर्शनल टू द स्क्वायर ऑफ इलेक्ट्रिक एंड मैग्नेटिक फील्ड और मैग्नेटिक फील्ड. सो अगर मैं इंटेंसिटी की बात करूं, इट इज हाफ एप्सिलॉन नॉट E नॉट स्क्वायर C और हाफ B नॉट स्क्वायर C अपॉन म्यू नॉट वॉट पर मीटर स्क्वायर. एक यूनिट एरिया में what is the power dissipated by EM waves? So the simple power की बात नहीं होती, एक यूनिट एरिया में कितना, that is what is called as intensity, a very special parameter attributed to EM waves. Next is an EM wave transports linear momentum as it travels through space. If it transfers a total energy U to a surface in time t, the total linear momentum delivered to the surface is U upon C. So अगर EM wave है, it is traveling through a surface, on a surface, etc. etc. It transports momentum through it. And what is that? Governed by U upon C, energy upon velocity. When it falls on a surface, it exerts, अब surface पे डल रही है. For example, X-rays है ना, हमें हमारे बॉडी के बोन्स को स्कैन करने के लिए, तो वो क्या करते हैं? When EM waves falls on a surface, it exerts some pressure. उसका क्या नाम होता है? रेडिएशन प्रेशर. एंड इट इज गवर्न्ड बाय I upon C. अब किस डायरेक्शन में मूव करना है? It is governed by mathematically the cross product of electric and magnetic field as written on the screen. So this will govern the direction of propagation of wave. Mind it, waves are traveling in all the directions. लेकिन मैंने उनको रिजॉल्व करके जो अभी अंडर स्टडी आई एम कंसिडरिंग, आई एम जस्ट रिजॉल्विंग एंड स्टडिंग द वन डायरेक्शन, राइट? Practically speaking, it is traveling in all the direction, and hence we need to polarize it, because unpolarized light has all the components of electric fields and magnetic field in all the directions, and hence propagation is also in all the direction. और सारे components को अगर मैं निकाल दूँ, एक ही component, एक set रखूँ, तो E, then B, and then the perpendicular में E cross B की direction, E cross B की direction जो EM wave की direction है. So EM waves, अगर EM waves को किसी electric field या magnetic field की presence में रखो, it is not deflected by them, and they obey superposition principle, are very important when you study the mathematical aspects of EM wave. So coming over to my last slide, a very famous and hence very descriptive in any and every sense we deal to physics and research and studying into the core. It is called as electromagnetic spectrum. As I mentioned in the beginning slides, electromagnetic spectrum is the range of all frequencies of electromagnetic radiation. Now imagine electromagnetic spectrum to be a road of energy, that rainbow road of energy, wavelength and frequency. On one end of the rainbow we have radio waves. This is responsible to give your send messages from one end to the other end via ionosphere to our mobile phones. We use radio waves. Next in line is microwaves. You can consider it as the tiny chefs there in our kitchen preparing or cooking food for us and under the presence of microwave radiations. And the same is responsible for sending messages in wireless mode from our mobile phones. Going further in line, we have infrared radiations. What they do, we feel cozy and heat. We do not see this, but we feel that the heat we feel, that heat mapping or thermal imaging we have is because of this infrared radiation. You know, our TV remote, it communicates with the TV through the same infrared radiations. The next in line, coming up next is visible, the most familiar part of the electromagnetic spectrum. Even if you don't know physics, all you know is visible or light radiation. This is the thing we see from, this is the rainbow we see. This is the whole electromagnetic spectrum is a rainbow of different wavelengths, but this is the rainbow which we see, a rainbow of 7 colors from violet to red. Violet has the least frequency, violet has the highest frequency, red has the least frequency. So these all 7 colors constitute our visible region or radiation by which we perceive the world around us. Coming up next is ultraviolet radiation. This radiation, what it does, we get this from sun directly. It helps in photosynthesis. It gives sunlight to the plants, which is there crucial to maintain the photosynthesis in the to trigger photosynthesis and, you know, prepare food for plants. It gives us, you know, it is also essential for our body. It gives us skin tan, but if taken in huge amount, it can also cause sunburns. Coming up next and the second last is X-rays. These are, you can consider it as spies of EM spectrum. It goes and checks the variety of structures. Scientists and doctors use it to check the structures of various materials or matters around us. Even the bones, it penetrates our body and skin and scans the whether there is any you know, irregularity or cracks in our bones or structures, etc., etc. And the last but not the least is gamma rays. You will never see it, which is there out in the universe. You will see it in the gamma ray burst, supernova explosion, during star formation, this and that. So this is used in studying of the intricacies or, you know, the details of the universe, that how the universal phenomena is taking place. That is the huge amount of radiation. Our human body cannot bear that. So the whole thing is just a saga of learning from, you know, the basic messages from radio waves to studying the knowledge of stars. All these things, when we want to study, the scale which we have been provided by the designer is electromagnetic spectrum. With this, I would like to stop my talk for the day, and yes.
थैंक यू सो वेरी मच मैम फॉर दिस इंसाइटफुल सेशन. मुझे पूरी उम्मीद है कि हमारे सभी व्यूवर्स को बहुत पसंद आएगी. यहाँ पर हम कुछ क्वेश्चंस आपसे लेना चाहेंगे मैम. इफ़ यू टॉक अबाउट इलेक्ट्रोमैग्नेटिक वेव्स कैटेगरी, तो हम ये आपसे जानना चाहेंगे कि इलेक्ट्रोमैग्नेटिक वेव्स जो है वो किस कैटेगरी में फॉल होती है, यानी कि किस कैटेगरी में आती है, लॉन्गिट्यूडनल और ट्रांसवर्स मैम.
ओके, सो आई वुड लाइक टू स्टार्ट इट विद एन एग्जांपल. हमें पता है साउंड वेव्स में जो एयर पार्टिकल्स हैं, दे आर नॉट ट्रैवलिंग अप एंड डाउन टू द डायरेक्शन ऑफ मोशन. दे आर ट्रैवलिंग टू एंड फ्रो. डिस्टर्बेंस इज ट्रैवलिंग टू एंड फ्रो. दैट इज अ लॉन्गिट्यूडनल वेव. बट अनलाइक दैट, अगर मैं स्ट्रिंग लूँ, स्ट्रिंग में मैं ऊपर नीचे मोशन करूँ, दैट ऊपर नीचे वाला मोशन इज गिविंग राइज टू स्टैंडिंग वेव्स विच इज इन अ फॉर्म ऑफ ट्रांसवर्स फैशन. बट दैट इज नॉट द केस विद EM वेव. मैंने जैसे बताया था, अगर आपको ये सब चीज़ें, अगर दोनों के बीच का डिफरेंस समझ में आ गया है, इलेक्ट्रिक फील्ड और मैग्नेटिक फील्ड आपको पता है ना, दे आर ऑसिलेटिंग इन परपेंडिकुलर डायरेक्शन पहले तो अपने में परपेंडिकुलर है, फिर जो डायरेक्शन ऑफ प्रोपगेशन भी परपेंडिकुलर है. सो इफ दे आर इन नॉट सेम डायरेक्शन बट perpendicular direction, तो which category will you attribute it to? Transverse waves. Yes, you are correct.
So transverse waves हम कह सकते हैं मैम. as you told us about the photons कि वो speed of light से travel करती हैं, but दूसरे particles नहीं करते मैम. why?
Okay, very good question. We know that photons, we attribute light as photons, as a series of discrete photons. Yes, wave particle duality, a different topic. However, you know what? Yes, हम उसको particle बोलते हैं. In what sense? बाकी particles, जितने भी तरह के particles उठा लो, उनका अपना mass होगा. Unlike that, photons एक special category of particles है जिनका कोई mass नहीं होता. अब अगर mass है तो they will never be able to travel with the speed of light, which is c. हमेशा नॉर्मल पार्टिकल्स की जो स्पीड है, लाइट स्पीड है, वो c से कम ही होगी. लेकिन जो फोटॉन्स है, दे आर मासलेस पार्टिकल्स. दे ट्रैवल सिंस दे डोंट कैरी इन इटसेल्फ द इनहेरेंट मास प्रॉपर्टी. दे ट्रैवल विद व्हाट यू कॉल इट एज द स्पीड ऑफ लाइट और c.
Ma'am, why rays, radiations and waves are different words, right? But are used in discerning electromagnetic spectrums, ma'am?
Yes, thank you for your question, and this is also a very meaningful question. We have seen in the electromagnetic spectrum, we say radio waves, microwaves, infrared radiation, X-rays, gamma rays, ultraviolet radiation and so on. तो कभी हम waves बोलते हैं, कभी हम लाइट वेव्स, कभी हम रेज बोलते हैं, कभी हम रेडिएशन बोलते हैं. दे ऑल आर सिमिलर बट थोड़ा सा सिनोनिम्स हैं, समझाने के भाषा में अलग अलग हैं. रेज कब हम यूज करते हैं? एक्स रेज, गामा रेज, बीटा रेज, अल्फा रेज. ये क्यों यूज करते हैं हम, कब, किस कैटेगरी में यूज करते हैं? जब मैं ये बताना चाहती हूँ कि माई रेडिएशन इज ट्रैवलिंग अलॉन्ग अ स्पेसिफिक पाथ. इट इज अ रेडिएशन विच इज ट्रैवलिंग अलॉन्ग अ पाथ. दैट एट्रीब्यूट कि ये वो पाथ में ट्रैवल करती है, वो किस, उसके लिए हम क्या यूज करते हैं? रेज. अब आ जाती है बात रेडिएशन की. रेडिएशन हमने सुना होगा ना, ओहो वहाँ एक्सरे वाले रूम में नहीं जाना, वहाँ बहुत रेडिएशन है. तो उसका क्या मतलब है? मतलब उसमें एनर्जी है एंड दैट एनर्जी कैन हार्म यू. यू नो दैट एक्सरेज आर हार्मफुल फॉर इट. तो अगर मैं रेडिएशन की बात करूँ तो मतलब समथिंग विच कैन कैरी एनर्जी इन इटसेल्फ. तो वो डिस्टर्बेंस और प्रोपगेशन ऑफ एनर्जी के लिए हम कौन सा वर्ड यूज करते हैं? रेडिएशन. है ये सबके साथ ट्रू, बट ये जो मीनिंग में थोड़ा थोड़ा डिफरेंस है, दैट इज व्हाट इट इज. लास्ट, वेव्स, जो सबसे मेनली हम यूज करते हैं. वेव्स तो अगेन मैथमेटिकली समझाने के लिए हम वेव्स यूज करते हैं, क्योंकि वेव्स का एक मैथमेटिकल लॉजिक है, एक्सप्लेनेशन है क्या होती है वेव्स. दूसरे तौर पे वेव्स कहाँ से जनरेट हुई थी? रिमेंबर माई फर्स्ट स्लाइड. ऑसिलेटिंग डिस्टर्बेंसेस व्हेन ट्रैवलिंग. अगर ऑसिलेट हो रहे हैं तो ठीक, लेकिन वो डिस्टर्बेंस जो ऑसिलेट हो रही है, जब वो ट्रैवल करने लगे, उसको हम वेव्स कहते हैं. तो वो वेव्स, उससे उसका नाम आया है. व्हेन डिस्टर्बेंस, ऑसिलेटिंग डिस्टर्बेंसेस और इलेक्ट्रिक एंड मैग्नेटिक फील्ड्स, ये जो ऑसिलेटिंग हो रही हैं, ये व्हेन ट्रैवल इन स्पेस, एक्स में ट्रैवल करते हैं, इनके इस फीचर को कहते हैं कि दे आर गिविंग यू अ वेव फिनोमेना. सो दीज थ्री आर सिनोनिम्स.
ओके, सो मैम हम अपने इस सेशन के एंड में पहुंच गए हैं. वुड यू लाइक टू ऐड समथिंग? आप कुछ कहना चाहते हैं हमारे सभी व्यूवर्स से?
Yes, I would like to add those who are in pursuit of science, or those who want to understand the deep mysteries of how stuff around us works. EM waves, electromagnetic waves, prove to be of a very important probe. We cannot study we cannot have scientific knowledge without the application of this electromagnetic waves. Everything around us, even the technological world, इसके पीछे अगर कोई है तो एक ही चीज़ है, electromagnetic wave. Not एक ही चीज़, but this is the main thing, electromagnetic wave. Yes, thank you so very much मैम. और जैसे मैम ने बताया कि उन सभी इम्पॉर्टेंट चीज़ों में से एक इम्पॉर्टेंट चीज़ है इलेक्ट्रोमैग्नेटिक वेव्स, और आई एम क्वाइट श्योर कि ये सेशन आप सभी के लिए बेनिफिशियल रहा होगा. और एक बार फिर से हम जाते हुए मैम आपको बहुत बहुत धन्यवाद करते हैं. थैंक यू सो वेरी मच.
थैंक यू मैम कि आप स्टूडियो आए, आपने अपना बहुमूल्य समय हमें दिया और इतनी अच्छी बातें और इतनी अच्छी तरह से ये सभी बातें हमारे सभी व्यूवर्स तक पहुंचाई। आपका बहुत बहुत धन्यवाद। हम यहाँ पर अपने सभी व्यूवर्स के कहना चाहेंगे आपका भी बहुत बहुत धन्यवाद कि आप पूरे सत्र में हमारे साथ रहे। थैंक यू सो वेरी मच फॉर योर कॉमेंट्स एंड इट्स टाइम फॉर मी टू रैप अप दिस सेशन। लेकिन हम आपको बता दें कि आप हमारे यूट्यूब चैनल NCERT ऑफिशियल पर जाकर हमारे कोई भी सत्र आप वहाँ पर जाके एक्सप्लोर कर सकते हैं। आप ज़रूर एक्सप्लोर कीजिएगा और अपनी बातें आप हम तक पहुँचाते रहें, अपना फीडबैक आप हम तक देते रहें। और इट्स टाइम फॉर मी टू रैप अप दिस सेशन। मी रेणु भट्ट along with my whole team is taking your leave and you stay healthy and take care. Namaskar.